This session we're going to talk about whip, whip, whap. Whip, whip, whap is a way to add or subtract fractions without finding a common denominator. Now this is a diagram showing you how you whip, whip, whap. Really you're just cross multiplying. You have two fractions, a over b plus c over d. And what you're going to do is you're going to cross multiply a times d, put it up here, take the sign that's right here and put it right here, and then you're going to cross multiply the denominator of the first one times the numerator of the second, bc, and add it to the ad. And then you're going to divide that whole sum by b times d, as we're showing right here. So I've got an example here. We're going to add 3/7 plus 2/5. So first we cross multiply 3 times 5, that's up here, times 2, add that up here, and then we multiply across the bottoms, 7 times 5, shown right here. And then 3 times 5 is 15, plus 7 times 2 is 14, all divided by 7 times 5, which is 35, which is of course equal to 29/35. Now what I've done here on the left is I've showed you the old-fashioned way of doing this addition. We decided that the common denominator for sevenths and for fifths was 35. So we set it up, 3/7 is equal to some number over 35. Well, how do you get to 35 from 7? Well, you multiply by 5. If you multiply the bottom by 5, you need to multiply the top by 5 also. So you get 3 times 5 is 15, all over 35. So we've changed 3/7 into 15/35. And now you go down to 2/5, and what do you need to multiply 5 by to get to 35? It's 7. So you'll multiply the top also by 7. So you get 2 times 7 is 14, all over 35. So now our new fractions, or our new representation of those fractions, is going to be 15/35, it's right here, plus 14/35, 29/35. And notice we got the same answer, and that's a good thing. Here's another example. We have 4/9 plus 1/3. We again cross multiply 4 times 3, add to that 9 times 1, divide by 9 times 3. So 4 times 3 is 12, 9 times 1 is 9. Going to add those together and get 21. 9 times 3 is 27. And then we notice that 21/27 is not reduced because they both have a 3 in them. Because 21 is 7 times 3 and 27 is 9 times 3. So we cancel 3's out, leaving us 7/9. Now I just want to point out one small detail. You could tell in advance that you're going to have to reduce this fraction because 3 and 9 have a factor in common. They have a 3 in common. So you know that in the end, you're going to have to divide out at least that 3. Kind of interesting, huh? Next slide. Here's one. 2/3 take away 1/5. Now, in order to use whip, whip, whap, you must be adding two fractions. So one way to add two fractions when you have a subtraction is to add the negative number. So I merely change this minus into a plus and put the minus sign on one of my components here on the second fraction. And now I use the whip, whip, whap. 2 times 5, it's right here, plus 3 times the -1, and then divide that whole thing by 3 times 5. So 2 times 5 is 10. We're going to add that to 3 times the -1, which is -3, and then multiply 3 times 5, which is 15. And finally, we're going to add up 10 plus a -3, which is 7, all over 15. Again, on the left in the red, I went ahead and I changed 2/3 into 10/15, and I changed 1/5 into 3/15 to show you that 10 take away 3 is 7, all over 15, and once again, we get a same answer, which is a good thing. Here we have some mixed numbers. But there's two ways to approach this problem. First off, you can take the whole parts and write them as 7 plus 2, and then take the fractional parts, 2/5 plus 1/3, and do whip, whip, whap to this piece. So 7 plus 2 is 9. Over here we're going to go 2 times 3 plus 5 times 1 all over 5 times 3. Simplifying that, you get 6 plus 5 over 15. And you're going to add 9 to that. So 9 plus 6 plus 5 is 11 over 15. And the good thing about a mixed number is it's the whole part plus the fractional part. So 9 plus 11/15 is merely 9 and 11/15. All right, again, on the left, I've done the problem slightly different with a way you might be accustomed to. I did it by making the mixed numbers into improper fractions. You don't usually want to do this because it makes the numbers larger and a little more difficult to deal with, but I did it nonetheless to show you. So 7 times 5 plus 2 is 37 all over 5, plus 2 times 3 is 6, plus 1 is 7 all over 3. And now I use whip, whip, whap, which says take 37 times 3, add to that 5 times 7, divided by 5 times 3, and 3 times 37 is 111, plus 5 times 7 is 35, divided by 5 times 3, which is 15, and we get 146/15. Now we need to reduce that, or change it back into a mixed number. I chose changing it into a mixed number to see if I'm actually going to get 9 and 11/15. And sure enough, 9 times 15 is 135, and 135 from 146 is 11/15. So you get the same answer, 9 and 11/15. Finally, I'm going to do the difference of two mixed numbers. And I want to point out that when I subtract off 4 and 2/7, I'm actually subtracting off 4 and subtracting off 2/7. So I write 3 plus 1/4, because that's what 3 1/4 is, subtract off 4 and 2/7. Now the distributive law says if there's a minus sign outside of a set of parentheses, like there is here, you must put that minus sign on both terms inside of here. So I have to subtract off the 4 as well as subtract off the 2/7. And here I've just mixed my whole numbers together and put my fractional parts together. So it's 3 take away 4 plus 1/4 minus 2/7. But, and that's what I have here on this line, you notice that 3 take away 4 is a -1, and we rewrite the 1/4 minus 2/7 as 1/4 plus a -2 over 7, because you can always treat subtraction as plus a negative number. And now we use whip, whip, whap on the fractional parts. 1 times 7 plus 4 times a -2 all over 4 times 7. We come down and simplify some more. I have 7 plus a -8 all over 28, which is equal to -1 minus 1 over 28. And it just so happens -1 can be represented as 28 over -28. I have really and truly -28 minus 1 all over 28, which is the same thing as saying -29/28.